Okay, will do. Okay, good morning, everybody. This is Eugene Arbogast from HV Technologies, and we want to welcome you this morning to our webinar with regards to the fiber optic links that have been developed by Montena Technology, a Swiss company. We are, HV Technologies is a North American distributor for Montena. We've been in business about 25 years. We have a number of other product lines affiliated with EMC. And but today, we just want to highlight these fiber optic links from Montena, which have come out of, there's a lot of EMC applications as well as maybe even applications beyond EMC. So we'll go ahead and get started.
Hey, Gene, before you
Mm-hmm.
begin, I just want to add that your cameras and mics are turned off for right now, but if you have any questions, please just drop them in the chat box and we'll be glad to answer them. Okay.
Okay. So we're going to talk today about a little bit about the Montena Fiber Optic Links. They've been designed for real-time measurements, pretty much in harsh electromagnetic environments. Basically, they're strongly shielded. It's a measurement head or a transmitter connected with a fiber optic cable, and again, suitable for harsh electromagnetic environments, high-powered electromagnetics, high-powered fields, high voltage areas, and also areas that are hard to reach. For example, the top perhaps of a radiating line or an antenna tower where you want to have a sensor. These can be placed pretty small form factor, and they can be placed pretty much at a in the hard to reach locations, because we do have a method of remote controlling them from the standpoint of power and configuration. Essentially, there's 4 versions of the fiber optic links. You'll see here at the top, you can see the frequency bands that they cover. The MOL 3000, which that's how we call it, the MOL 3000 was the first fiber optic link developed by Montena, 80 hertz to 3.5 gigahertz. It's basically a 0 dB gain. It does not, you'll see later on here, well, and actually the next set of fiber optic links actually has a variable gain control, the MOL 2000T. But the MOL 3000 was the first and pretty much came out of the testing for mil standard 461 RS 105 radiator susceptibility testing. Basically the high altitude electromagnetic pulse, which is a simulator that Montena has developed, the RS 105 test system. So that's the MOL 3000. The MOL 2000T, as I mentioned, adds the variable gain and that gain can be remotely controlled. You'll see a little bit later some of the configuration software that we have for that. And then more recently, they've developed a couple of other fiber optic links, DC to 500 megahertz, basically to be, and then the DC to 25 megahertz, basically can be remote controlled with the 1-to-1, 10-to-100 to 1 attenuation, and 1 mega ohm or 50 ohm inputs. The key here in these last two is that they're very suitable to be pretty much an oscilloscope, if you will, an oscilloscope front end or an oscilloscope head. And then for very long distances, you basically have your oscilloscope head, which is the transmitter, and then you can have up to a half kilometer or even more of fiber optic back to the receiver and then to your oscilloscope. So all of these, for the most part, all act obviously as a measurement head in these environments, and also putting a good deal of distance between you and the control room or yourself, and if there's a hazardous area, or again, as we talked about, very strong electromagnetic fields. So basically, they're battery powered. The transmitter modules are battery powered. That's in all versions. And then there's basically 3 receiver options. There's what we call, a lot of times we call it the point-to-point transmitter receiver, battery powered, which is both of these are then battery powered. The transmitter and the receiver are battery powered. They look pretty similar in terms of form factor. And then we have an option to put these either in a single slot chassis or a multiple slot chassis that is powered by 120 volt mains power. So the single slot chassis and the multiple slot chassis give you a little more flexibility on the receiver end from the standpoint of power and configuration. So as I've mentioned a couple times already, each model is EMC shielded. Coming out of the RS-105 test environment, the EMP test environment, they've been tested up to 1 megavolt per meter electric fields. And just here, a little bit of a display of the type of electric fields that you could encounter, and what these links can withstand. So again, excellent shielding when exposed to high-powered electromagnetics, designed for real-time measurements. They are suited for outdoor environment, not really influenced by temperature variations, humidity, or even the optical cable quality. It's a scalable system. I'll get a little more into that as we go further into the brief or into the presentation. Fairly easy to deploy, and with the configuration software that we have with that, fairly easy to control and configure, especially the transmitters, which, as we've mentioned, may be in a remote area. They're again small acquisition modules. Form factor is about the size of let me see here. I guess about maybe 4 or 5 inches, 3 or 4 inches high. So they're pretty small and easy to place. And they also have the transmitters are battery powered, and they have a good. They can last. We've actually had them out for several days, up to weeks, 2 weeks, and that's with the configuration software we can, shut them down, turn them back on, put them in standby mode. So although battery powered, they can last quite a while. I think continuous operation, they'll last about 24 hours. So we call this the configuration software, the fiber remote software application. There was both a Windows and an Android version. Android version for the point-to-point links, and then the Windows version for both point-to-point and the rack-mounted receivers that we talked about earlier. Basically, this is just for configuration and monitoring of the optical links. This is not in itself measurement software. This is basically configuring and monitoring. Next, as you see here, this is kind of a sample of what you get in terms of the fiber remote software and the settings and the configuration aspects that you can see with that software. And all of this is controllable either, again, with a Windows PC or with a Windows PC. Again, the Android version is also possible with a tablet. Let's see here. Status of the outbound link. Okay. So that's their typical applications. Kind of run through those. I mentioned the fact that Montena developed these pretty much out of their nanosecond pulse type work that they've been doing with EMI and EMC testing. And that's where the MOL 3000, the MOL 2000s, MOL 3000s and 2000s came from. More recently with the MOL 25s and the MOL 500s, we're talking more about voltage and current measurements, monitoring AUT signals, and shielding effectiveness tests, whereby you can, if you're looking for residual voltages or residual currents, when you're doing shielding effectiveness tests, the sensors can be hooked to these fiber optic links to then get get those signals or get those readings out to your oscilloscope. Also, it's a good front end oscilloscope module, particularly the MOL 25 and the MOL 500, or for precise floating potential measurements, troubleshooting, and like in a power distribution network and HV substations, where there may not be the monitoring that there may be some areas or some measurements you want to take that may not have in the power distribution network that may not be monitored on a continuous basis. And then precise floating potential measurements and power converters, and of course synchronized real-time measurements over a long distance. So kind of going back to the list I just went through for EMI, EMC tests, you'll see you'll see the RS-105 radiating line that is actually out in Switzerland, but these are systems that we distribute here in the U.S. for Montena, and that's one of the key. This is one of the key systems or tests that these have been used for: the NEMP, ultra wideband pulse current injection, lightning testing, and HERV. The rack-mounted solution basically allows you to, if you may have measurements that you're taking over maybe a broader area or in several relatively remote or hard to reach locations, but you can bring all them back to a receiver and to a receiver chassis, and have that all brought back into a single location. What you'll see here is let me see here. Let me do this. So what I'm showing here, this is one of the examples. This is a D-dot electric field sensor, actually a free field electric field sensor, many times configured for RS-105 type testing. You'll see here that this is the D-dot itself, the balun, balanced for the, and then of course in back here is the MOL 3000 or 2000 transmitter to the fiber optic cable, and then back to your receiver, your MOL receiver, and then to the oscilloscope. There's also, Montena has developed, again, going back to the lightning test or the electromagnetic pulse type testing, they've also developed Pulse Lab software, and this software is for actually doing measurements. Your transfer functions of the measurement change can all be entered. Probes, attenuators, the fiber optic links themselves, coaxial cable, also integration, signal integration when you're using the differential derivative sensors, either magnetic or D-dot derivative sensors, because that's what you're getting. You actually are getting the change in current or change in field, and of course that has to be integrated at the end to recover the pulse or the measurements that you're actually looking for. Pulse Lab also helps with the oscilloscope, automatic setup, and generation of test reports. So we talk about this with Pulse Lab. We usually bring that out to, it's optional. It's not required in order to operate any of the fiber optic links, but we bring that up because it does help with test control and reducing the risk of errors in your test and measurement setups. So just another example of a of a B-dot, D-dot field probe setup, several in either they could be distributed, or as this is kind of showing, in a single location, but they could be distributed around an area that you're trying to get electric field measurements for. And of course, then you can bring those all back to your receiver chassis. Up to 10 receivers can be included into the chassis. And the other interesting thing as well is that you can mix in the receiver chassis. You can mix the MOL 25, MOL 500, MOL 2000. You can mix those receivers with the corresponding transmitter front end. So in other words, the chassis can house. You don't need a different chassis for each of the different versions of the MOLs of the MOLs. The single chassis accommodates all three versions.
Hey, Gene, before you move
Yeah.
on, Kevin has asked, assuming there is a list of scope drivers or compatibility list.
Pulse Lab, they will generally, if you let it, what we need document that we do send out with the Pulse Lab software when people, well, when anybody expresses an interest, which we could do. It's pretty, the oscilloscope compatibility with Pulse Lab is pretty wide. It's a pretty long list, so it's pretty good. But Montena has in the past developed additional drivers for oscilloscopes. But I would tell you that the risk for compatibility between Pulse Lab and your oscilloscope is pretty low. They've had these out now for several years, and I would say it's LaCroix, excuse me, LaCroix, Keysight, Rodian Schwartz, all of the various models. There's quite a few that are all deemed as compatible. I don't know if does that answer the question? Okay.
Also, sorry, John has asked, does this system use single mode or multi-mode fiber optic cables, single fiber to duplex?
Let me see here. We have the MOL 3000. Let me see here. I'm just checking that out. That's a good question. That's a question we get. Let me see here. We typically will provide the corresponding fiber optic cable, usually with these. Let me show you. I'm trying to find that here right now. Let me just take a look on that. Well, I don't have it in front of me right now. I do have a list for each of these of the type of fiber that they will that they can that they do use or that is required. So let me, if I could, I'll try to follow up with you. I can email you a data sheet that I do have on that, but I do not have in front of me. But yes, generally it's the optical connect. It's usually FC and ST connectors. But I'll have to get back to you really. So let me we'll take a note here and get that out. I do have a data sheet on the type of fiber optic cable needed for each of these links. So just a little more, again, kind of emphasizing the whole idea of that they are highly shielded, small, compact, battery powered, and versatile inputs, 50 ohm to 1 meg ohm inputs. Just an example, I talked earlier about shielding effectiveness testing and the use of these links. They would basically, you would have your optical fiber here going from the facility under or system under test. Your optical fiber there taking measurements, getting both measurements from the transmitting antennas and then measurements, the residual measurements that you're getting from the receive antennas in the facility under test. One of the aspects that we see a very good application for. We do have a power company in Canada that has been using the MOL 500, the DC to 500 megahertz uh, fiber optic links. And what we find there for them is that, again, kind of as I mentioned earlier, troubleshooting in the power grid and in substations where perhaps you don't have the constant monitoring that the power industry typically does. The good thing is that, obviously there's total insulation between the measurement point and the operator. It's ideal for measurements on floating potentials. And again, the versatile 50 ohm, 1 mega ohm inputs. The MOL 25, the DC to 25 megahertz is a two-channel system, and that's another area that we see application, particularly in the case of the power utilities. Kind of mentioned that again, measurement of fast transients. You may recall again on the RS-105 test signal or test pulse. That's a 2 to 3 nanosecond rise time pulse, and about anywhere between 20 and 23 nanosecond pulse width. So coming out of that development, pretty much these fiber optic links are ideal for the measurement of fast transients. Of course, I mentioned earlier as well, synchronized measurements, simultaneous measurements of fast transients at multiple locations. Being a Swiss company, Montena has had several applications to the railroad industry in being able to look across, be able to synchronize measurements between distributed motors, power converters, and power supplies across for example, across the train, a passenger train lineup. They've had quite a bit there, and we've started to get some inquiries from the railway industry. But of course, the railway industry here in the United States is a little more, probably not quite as, as robust as what we see in Europe. But there's definitely applications to the railway industry as these go further. Okay, that kind of sums up everything. I know